All right, so now we have spoken about the confidence interval. There's a closely related concept. So now, the confidence interval we calculate after we've taken our sample size, but there's another quantity called the predictive interval. And we've seen this before, of course, but let's apply it to the sample mean. Now, the predictive interval was the one that we've seen is we said, all right, if we've got a standard normal variable, there's our friend z, so we've got the variable x, subtract the mean mu, divide by the standard deviation sigma, then we know that 95% of the time that we observe such a variable, 95% of the time, it's going to have a value between minus 1.96 and 1.96. Okay, so there is that statement. Now we can just multiply through by sigma, add mu to both sides, and what do we have? We end up with this statement. This is called a predictive interval. Before we take the value of our variable x, whatever it is, we can predict that 95% of the time we do that, we're going to get a value that's within, say, 2 standard deviations of the mean. That's predictive. Before we actually see anything, we can predict that. There it is. So now, this is a predictive interval for x. What about x bar? Well, x bar, the central limit theorem tells us, is also normally distributed, but with the same mean, but with a smaller standard deviation, the standard error. So what we can do is, instead of using sigma as the correct standard deviation, now the correct standard deviation would be sigma over the square root of n. So a predictive interval for the sample mean, when we take a mean of a sample of size n, is this interval here. So 95% of the time that we take a sample from this population that has a mean mu and a standard deviation sigma, the central limit theorem tells us that this is where your x bar is going to end up. This is in contrast to what we've just seen, which is the 95% confidence interval. Okay? This we calculate after we've taken our sample. So the confidence interval is ex post, the predictive interval is pre. Let's go back to our total cholesterol. The mean of the population, remember, we're still dealing with our population where we've actually calculated it. We know everything about it. So the mean of the population was 237. The standard deviation was 44.7. So we would predict that 95% of the time that we choose an individual from this population, calculate the total cholesterol level for that individual, we will get a value that's between 149.4 and 324.6. Now, if in fact we took that's the 95% predictive interval. If in fact we took the mean of such a sample, then the mean of such a sample would be between 224.5 and 249.5. So much smaller. This interval is much tighter than that interval. And that's because the mean of the sample is much less variable than the population measurement. Remember, population measurement, sigma, sample mean, sigma over the square root of n. And then lastly, that's the predictive interval for x bar. And then here we have the confidence interval for mu. So the confidence interval in this case is 221.2 to 246.2. In this case, we're successful because mu of 237 is covered by this interval. So in this case, we got boing, we covered it. So we're in the 95%. We didn't hit the 5%. So note the difference between these two, the predictive interval and the confidence interval. The predictive interval is where will the mean lie. Now that we know where the mean has plonked itself, what can you tell me about the mean of the population from which I got this sample?